Hi, I am Tsahi Levent-Levi of blog.me. Today we're going to review real-time media and network resiliency and what exactly that means for a live video platform. And I'll start with what I reminded you last time, and that's that live video is really hard. I'll add to that one more thing, and that's that the networks that we are using aren't helping us any. They're not making things easier on us. Now, to give you an understanding of why that is, you need to remember that you are not in control, especially not with today's live video platforms that use WebRTC. If you look at this architecture, we've got a kind of a media server that routes the media around. It exists for a lot of the different applications that you are going to build with live video. We've got one user on a browser and the other on a mobile device with an application. So if I had to mark them up, then that guy in the browser, that's mostly not your code that he is running. You're not in control over there. Now, on the media server, that's your code. That's where you control things. Now, that other guy on the mobile device might be your code, it might not, depending on how you've built it. And then on the network, that's definitely not under your control. You can do nothing about it. Now, why that is? Why do we have an issue with the network? It's because networks are messy and unpredictable. If you think about it, networks cause these different errors on them. The first one is packet loss. If I'm going to send multiple packets on the network, some of them may arrive, others might not. There's also duplication. I can send packets and then one packet might be received on the other end more than once. So I'm now dealing with duplications. Then there's reordering. If I'm sending packets in a given order, they might be received on the other end in a different order than what I've sent. And to top it all, we've got jitter on the network, which means that when I send the packets in a given frequency, they might be received on the other end on a different frequency. If I'm sending a packet every 20 milliseconds, the other end might get a burst of several packets at once, and then have a delay or latency or jitter of like say 50 or 20 or 80 milliseconds before the next packet arrives. And again, our video platforms run live and they do things in real time, and we need to take care of all of these problems that happen on the network. So what should we do with packet losses? What are the things that we can do to improve a problem when we see packet loss, when there is an error on the network? The first thing we can do is, well, to reduce the bitrate. This is needed, for example, if what we experience on the network is congestion, if we're trying to send more than the network has in terms of capacity. Second thing you can do is we can try to conceal it. That happens on the receiving end. Okay, I can see that packets aren't arriving, and I can estimate what these packets should be in order to conceal that problem and do something about it. Last thing that we can do is increase resiliency. Decide that what we see is corruption, okay, packets not being delivered because the network is just poor, and it doesn't matter how much bitrate we're going to send, it will stay poor. And then we can add things like forward error correction or other techniques to increase the resiliency of the data being sent. So if we are losing packets, we're not losing actual data, or we can fix it on the fly. We can also do all three at the same time, a combination of them dynamically. Now, there are a lot of things that we need to consider when we're dealing with network effects and the problems with networks. The first one is we need to understand what's the available bitrate that we have, especially with video, because video is going to take up a lot of network resources. If we know how much bandwidth we have available, what's the bitrate available to us, we can decide to send that amount of bitrate and get the highest quality possible. There's issues with network latency and the characteristics of the network, how it is behaving. This is going to affect, for example, how we're going to handle lip synchronization between audio and video, and how much delay we're going to add, and how much we're going to wait for a packet before we deem it as a lost packet. Is it congestion or corruption? Are the packet losses we're experiencing related to congestion on the network or a corrupt network to begin with? Are we going to be proactive or reactive with these problems? Are we going to try in advance to know that things are going to deteriorate and act upon them without them actually happening? Okay, predict that thing. Or are we going to react to a packet loss by then doing something? Then there are the device capabilities. The device might be capable to doing one thing and not the other. We might have, limited CPU available to us or network that is locally low. And we also need to understand that all of these issues are dynamic in nature. The network characteristics may change dynamically throughout the session. We can start with high bitrate and no packet loss, and then after a minute or two into the call, things deteriorate because I'm using a mobile device and I move to a different location, or because Google Drive decided to start uploading data into the cloud at the same time that I'm doing a call. So all of these things change dynamically, and we need to take that into consideration. So remember, you're not in control. Wherever you run your code, you control things, but it needs to take into account a lot of things that are out of your control. And that's where the know-how of building live video platforms comes into play. Thank you, and see you next time in how to pick a live video platform.